같은데.
아니 음료수 그거밖에 없어.
어제 이윤재가 허쉬 초콜릿 키세트 특이한 맛 좋더라.
코코아 맛.
그런 게 있어.
다 초코
뭐?
맛이야.
미국산이야 미국산.
아 배불러다.
그래서 얘는 안 뛴대.
어?
안 뛴대.
아 배불러.
너는 안 뛰어?
안 뛴다고 별로.
왜 안 뛰어 너네?
그래서 대책방을 정해야 되는데
줄넘기에
줄넘기를 그러니까
줄넘기 진짜 이청이 진짜 겁나게 힘들어.
그러니까 니 저번에 야 식당에서 어이가 없네.
나 학원 나 지금 나 이청에 못다 나 오늘 1,700개 하고 왔거든.
아니 저기요 식당에서요
내가
느낌으로.
내가 하는데 너가 못한다고?
아니 나 한 번에 나 안 쉬고 계속.
이윤재 처음에.
야 그러면 다음에
아니
못하지.
나도 걸리고 안 쉬고 계속 하지.
나 한 번밖에 안 걸렸어 오늘.
자기 잘났대.
그게 진짜.
잘났대.
이청이 아직 안 하고 있어 그래서 너무 힘들어. 발바닥 안 아파? 발바닥.
난 종아리가 아프던데.
너 종아리가 아파. 종아리.
아
줄넘기를 하면 좀 종아리가 아프대요.
We have to exercise, but they said they don't exercise now.
yes why?
We did very bad today.
7, 9.
운동하는 게 좋아요.
네.
Yes. You play tennis. And
Yeah, I will make everybody exercise. I can make you exercise, you'll die.
미국에 있냐? 안 듣는데.
Harder than that.
인터넷 어때? 응, 이거 속상 들어가면 돼. 여기서 돌려봐. 여기 상태를 봐. 됐어 그러면. 이거 보고 하는 거야.
You understand?
So someone said that lose a weight.
That's so mean. You can't say that in America. If you comment, especially if it's a girl, if you comment on girls' weight in the US, it's so rude. It's like the most rude thing you can do.
Ah.
Stop.
Say the girl's weight.
절대 안 돼요.
In Korea it's saying
괜히 마우스 따지잖아, 아줌마.
girl's weight is secret.
No, but they always call them fat. Like you call girls fat. Like in the US, if you call a girl fat, like even if she is fat, if you call her fat, that's like terrible. Never do it. Never.
Also in Korea, men has secret that their height, men's height is secret, and women's ages and weights are secret.
Height, yeah. You guys have a weird thing about height in men. It's like everyone wants to be tall in Korea if you're a guy.
But
But
American people are very tall.
that's why they don't care. They don't care it's like tall or not. But yeah, no, don't call people fat. Every time someone says something like that or like lose weight here, I feel so uncomfortable because I'm used to it being like, whoa. But then you have like mothers like Atama who just like call people fat. And I said, okay, so no one likes trigonometry, which is like cosine sine, but I sent that because you might be interested to
I saw.
see how the graph works, but it's not as fun. So we can do something else. So what I had in mind, like for last time instead, but we got sidetracked, was this set. So
Set notation.
set notation, and also I have a fun problem
Oh,
that
yes.
might be kind of hard for you guys, but
Oh?
no, but it's really easy once you get it. It's just like it takes some. It'll take a while. Okay. Okay. So what is a set? Can you tell me?
Group?
Yeah. So it's usually denoted like this, with like the squiggly brackets, and then you'll have some elements, right?
Yes.
And that could be a set of 4. These are elements. And we'll usually denote this like some letter. So you could call it S.
S is set.
Yeah, so S in this case, S would mean this, the whole thing. So you could have A equals 1, 3, 5, 7, right? And so A would be, so that would mean that A is the set of all odd numbers, right?
The minus number can't be odd.
All positive. I mean, you could have minus odd
Or
numbers.
positive.
Yeah, positive, because greater than 0, right? And then let's call B. Let's have B be 0, 2, 4, 6. So this is the set. Set of all non-negative even numbers.
Negative. Why is negative?
Non-negative.
Non-negative.
Non-negative. Alright, so not negative. That means 0 or more. Okay. So, and then we have these things that this is intersection, right? Union, right?
I have a question.
Yes.
0 can be even number.
0 is an even number. Why?
Oh.
Why?
I will.
It's divisible by 2. Yeah.
Infinity can even and odd both.
Well, they go to infinity. Like this would be like some huge odd number, right? This would be some huge even number. You could erase it, but it just goes on forever, right? It's very easy to prove that there are an infinite number of even numbers. How would you do that?
Infinite will divide by 2.
Well, how do you know there's an infinite number of even numbers? Well, assume there's a finite number of even numbers. Then you can select a number n such that n is the biggest even number. Now consider n plus 2. Contradiction. N plus 2 greater than n, and if n is even, n plus 2 is even.
Yeah.
So that's a proof that there's an infinite number of even numbers. You can do the same for odd numbers. Okay?
Yeah. Okay.
Got it?
I forgot what that remarks mean.
Yes, we will talk, don't worry. Don't worry. Alright, so this is like, this means like and, right? And this one means or. Okay. So generally when we talk about these things, I like to draw it like circles. So let's say this is A, and this includes everything that's in A. Okay? And then here's B. Okay? Alright. So A and B. Everything in both A and B. So what would that be?
Oh, color orange.
This part.
Yeah.
So this is A and B.
Yeah.
Right?
Oh.
And the reason why it's called intersection is because this is the intersection. Right? They intersect each other.
Oh, this
So intersect is like
겹치다?
cross. Yeah. Overlap. That's overlap.
Overlap.
So this is like, consider that as like overlap. Intersect is more like if you think about two lines, they would intersect at this point. Point.
That's overlap point.
Yeah, overlap, intersect, similar. Overlap is more like if I put two things on top of each other, they overlap. Intersect is more like they cross. Okay. Alright, so A or B. Everything in A or in B or in both. Alright, so with A or B, we're going to use the blue marker. Tell me what I should mark for A or B.
Oh.
Should I mark out here?
No.
No. Alright, so I have to mark everything in A, everything in B, and everything in both. So, A and B is part of A or B, okay?
Yeah.
Alright. Now, I want you to think, when is A and B equal to A or B? And when is A and B equal 0? Alright,
The first thing is when is A and B equal A, or B is A and B is same.
yeah. What about this?
Not there's no intersection point.
Yeah, so that's what we would say A and B are disjoint. Okay. Disjoint, and that's when you have like two, and then there's nothing in common. Okay? Alright, so let's return to this. What is A or B?
All number. All positive number.
Okay, all non-negative integers. Alright, and what is A and B?
No, it's joint.
Yeah, so this thing means the empty set. Okay? So that means there is no elements. Nothing. Why is there nothing in A and B?
There's no intersection.
There's nothing that's in both. Right? Okay. Alright. So then I want to introduce just a couple more notations. Just a couple. Don't worry. It's not that much. So can I erase?
Yes. What is our purpose?
This is important math you need to know. There are a lot of problems you can do with sets. Fun problems. You need to know this too. You need to know this even if it's not even if it's not discrete math, which is what we've been doing, you still need to know this kind of stuff for all math. So pure math, any kind of math, you need to know this. Okay? Okay. And so we say that A is an element of A. What are you doing? You guys look so, you're like, A is consists of some elements. Basically, this means that A appears in A. Okay? So A is an element of A. Okay?
So this remark is element.
Yeah, this means like A is in A.
What?
Little a is in big A. Inside. It appears.
A is a set and a small a is element.
Yeah.
Little a include in big A?
Yes, it appears in the set. Okay? So you would say, let's let S equal A, B, C, D. You can say C in S and E not, so you cross it like that, in S. Okay? Alright. So, S prime, let it be different than S, okay, is a subset. This means subset
So
of S if it's like S prime has common elements. So if basically say S equals A, B, C, D, it would be like if S prime equals BC. So it's some portion of S, but has nothing. So S prime, S prime and S equals S prime, and S prime or S equals S. Yeah. Okay, so let's start thinking about this, right? So let's say S prime equals A, B, C, D. Is S prime subset S?
What is subset?
you can understand easily if you drawing a picture.
Yeah. Yeah. So S prime. It's contained within. Okay? It's inside. So let me ask you. Is S prime a subset of S?
Yes.
Yes. Because S prime equals S. Okay? So that's okay. It's okay. It can be that this is S and S prime. It could be okay to have it be the same one. Because and equals S prime equals S. Or it equals S.
Too fast. Are you?
Okay, think about it as like it's a portion of it. So it's like you have a pie, right? So S is your pizza pie, right? S, this is S, right? And let's have some slices, right?
Yes.
And so these slices, you can call them like S prime, right? Now you can eat this, right? You could eat these slices, or you could eat, these two and this, or you can just eat the whole pizza. Can you eat anything outside of the pizza? No, because it doesn't exist. Right?
Yes.
So think about S prime as representing how much of the pizza you eat.
So subset is only used between set and set.
Yeah, so subset means but okay, if, let's just say that S prime equals A. Just one element. One element, right? S prime subset S?
Yes.
Yes. Because A appears in S prime.
Yes.
This is like a less than or equal to sign, okay? Right? So this is like, it's like less than or equal to, but for sets.
Can you explain that S 다시는 and S equal S?
So, if this is S and this is S prime, what's the intersecting part?
Oh, S type?
Yeah. It's just that, right? That's what overlaps. Now if we say or, what's in both? Either or both.
S.
Yeah.
Got it.
Got it? Okay, so I started thinking about subsets, right? So I'm going to ask you like a little bit of more, slightly more challenging. So, here, remember this is B, right?
Yeah.
Let B prime equal the set of powers of 8. So what would this equal? Of all powers of 8, so it is 8 to the n for, let's let n greater than or equal to 1. Okay? So what would that look like? B prime equals 8 to the 1? 8. 8 squared?
64.
8 cubed? 640 minus 16. 624.
500.
Wait, am I being dumb? Oh yeah, 500 something, because 64 times 2, yeah.
512.
Yeah. Alright, 512. Alright, etc. Alright.
What is element?
It's like something in it.
구성요소?
부분. Just part, one thing. Something. Inside.
구성요소.
포함되어 있는 거 하나하나를 엘레먼트라고.
Okay.
Okay. Is B prime subset B?
Yes.
Yes. Okay. Okay. Alright. Now, let A prime equals the set of prime numbers. Is A prime a subset of A?
What is prime number?
It's like only divides by 1 in itself.
소수.
소수.
No factors.
No.
Yes! Good! I
Then
tried to
because
trick
there
you.
is 2.
Yes. So A prime equals 2, 3, 5, 7, 11, 13, etc., right? But because of this, it's not a subset. Because these are all odd.
느낌이 좋아서.
What is previous problem?
B prime is power of 8. B prime is 8 to the n for n greater than or equal to 1. Is it a subset of B?
No.
Wait, why? B prime is powers of 8. B is all even numbers.
Okay. Yes.
Yes, yeah. Okay. A is prime numbers. A prime is prime numbers. A is all odd numbers. Is A prime a subset of A? No. Okay. Cool. Alright. So, here's where we get into the fun parts. Okay, so we all know what a subset is, we know what an element is, we know intersect, we know union. Sort of, you know, well enough, you've seen it. Alright, now here's my fun question for today that I'm very excited for. Alright, so, let S equal the first 100 integers. How many subsets of S are there?
Oh, holy.
Alright, let's start thinking. Any ideas? How many total?
Oh,
Okay, well, first let's ask, okay. Let's ask, how many two element subsets?
I know.
Alright,
I is 100 times 99 divided by 2.
yes, why?
Because we have to pick two, but there's meets A and 2 and 2 and 1 is same, so we divide by 2.
So it's this thing, right? Yeah, 100 options, 99 options, but same if you reverse. So it's 100 choose 2.
10 factorial.
Well, 100 factorial divided by 2 factorial divided by 98 factorial, which is that.
Yes.
Okay, that was a little fast, I'm
So
sorry.
that 102
Choose.
means the
So, you weren't here for this. It was block.
Yes.
So 100 choose 2. So this is 100 choose 2, right? And it's the number of ways to pick two elements from 100. Sorry. Right? Okay. So it would be like, I have a drawer with 100 things. How many ways can I pick 2 things? Okay? And so just think about objectively, okay, if I want to pick 2 things from 100, tell me how many ways I can do that in your own words. So how many ways can I pick 2 things from 100? What? How many options do I have for the first one?
100.
Yeah. And how many for the second one?
99.
99.
Alright, but here's the problem. What if I picked item 10 and then I picked item 25? That is the same as if I picked 25 and then 10.
So we have to divide by 2.
So you have to divide by 2. Alright, cool. So, now let's think, how can I pick 3 items?
100 times 99 times 98 divided by 3 factorial.
Yeah. Because there's 3 factorial ways to arrange the 3 items.
3
Oh.
factorial.
You know what this is, right?
Yes.
Okay. Because if I have, say, A, B, C, I picked, how many ways can I arrange this?
Oh, 6.
Yeah.
3 factorials.
Yeah.
So if we have 100 items, we have to divide by 100 factorials.
So, hold on. So, n choose k equals n factorial divided by k factorial times n minus k factorial. Why? Because this equals, so this divided by this goes to n times n minus 1 times n minus 2 all the way to n minus k plus 1, right? And these are all the items that I'm choosing. These are k items, and then we divide by k factorial because this is the number of ways, number like over counting, right? 왜 몰라요?
We
왜?
learn.
그러니까 아니 떠들어서
아니 다시 배워요. 물어봐.
응?
물어봐. 뭐 이해 못해요?
If I ask that, we'll learn.
No,
hour.
it's okay. It's okay. We learned a long time then. Everybody needs to know this.
I remember we already solved that, but
Okay,
I
Robert,
forget.
how do you understand this? Okay? So, we need to understand why. Okay. I give you 3 colors.
네.
Pick two. How many options for the first one? How? 3.
저
Alright, you chose
저-
black.
나도 알아.
How many options?
2.
Alright, 2. You chose blue.
One. But I understand that, but I don't understand that formula.
The process.
It's the same.
Yes.
Okay, it's just we have n markers. I give you n markers. I want you to pick k. So, in this case, n equals 3, k equals 2. So it's like if I gave you, okay, let's say we have 10 books. So n equals 10. Okay? Okay? And then k equals 5. So you pick 5 books. And how do you do that? Well, how many options for the first book?
10.
10 equals n. How many for the second book?
9.
9 equals n minus 1. How many for the third book?
8.
8 equals n minus 2. 7 equals n minus 3, and then times 6 equals n minus 5 plus 1, where
Oh.
5 is equal to k.
Oh, yes.
Yeah, right? It's okay. Divide. How much you overcounted? Okay, you take 5 markers. They're all different, but you took them in one specific order. So you count too many. How many ways can you arrange the 5 markers you picked?
5 factorial.
Yeah, you pick them in a different order. So I can say you picked 3 markers, right? How many, so you picked blue, then red, then black. But that's the same as red, then black, then blue. It's the same as red, blue, black. Okay? Alright, so how many ways did you overcount?
Orange 3.
Arrange 3. Fix order.
3 factorial.
Yeah, because 3 for the first one, 2 for the second one, 1 for the third one.
Yes.
Okay? So divide by 5 factorial equals k factorial. Aha!
아,
See?
I
It's
know.
the same.
Bravo.
See, it's the same. Okay, okay. And then this is equal to, by definition, what is this? Alright, so this is n factorial. So this part is n factorial divided by n minus k factorial times 1 over k factorial. Because if you look at this, this is the beginning of n factorial. If we multiply, so let's look at, hold on, okay. So, we have n times n minus 1, dot, 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 times n minus k plus 1. Now I say, and we have this divided by k factorial. Let's multiply by n minus k factorial divided by, 1 over, sorry. Let's multiply by n minus k factorial divided by n minus k factorial. And this is 1. This is 1. Okay? What is this times n minus k factorial?
N factorial.
Yeah, why? So, what is this equal to? This is equal to n times n minus 1 times n minus 1 plus k plus 1 plus, times n minus k times n minus k minus 1 times 1
Yes.
divided by k factorial times n minus k factorial. Now this is all the numbers from n to 1 multiplied together. And what is that?
N factorial.
Yes.
Yes. So, this, which we derived as the number of ways of picking k items ourselves, is equal to n factorial divided by k factorial times n minus k factorial. And we say that that is n choose k. Okay?
So set relates probability.
Well, sort of, because how many ways can I pick how many 3-element subsets do I have?
10 choose 3.
Well, from here, we have 100 numbers.
100 choose 3.
Yeah, so we've got 100 choose 3. Now, I asked you for all the subsets, which I'm going to ask you for. What's the probability I pick a 3-element subset
All the subset.
out of all the subsets? If I take any random subset, what's the probability that it's a 3-element subset?
Oh. Oh. That's terrible.
It's terrible. It's the probability. Well, it's the number of 3-element subsets divided by total number of subsets. Alright, we know this is 100 choose 3.
But we don't know the below one.
No, we don't know that one yet. That's what you have to think about. There's a very nice answer to the bottom one.
Nice.
Very nice.
Very terrible now.
No, very, very nice. Very, very nice. How many total subsets? I want you to try and solve it, even if you think that you can't. And don't just sit there blankly and wait for the answer. It's very bad. I won't give you the answer. You have to think using what you know. So I ask you the total number of subsets. Any number of elements can be in the subset. So start writing.
A little confused subset.
Subset? So what's an example of a subset? Alright, well, let's say S prime equals 1, 2, 3, 50. That's a subset of S.
Okay, I have a question.
Yes.
The empty set can be.
Yes. That was a very good question.
I know.
You're arrogant too.
Did you solve it?
No.
No, you
I
did
just
not.
asked.
So yes, empty.
Empty is never true.
Empty.
What?
아저씨.
Why? I can't understand.
Empty, like okay,
Ah,
so
empty.
empty, but he said empty is membership.
Oh.
완전 아저씨.
그거 그래.
empty.
방금 그 얘기한 거지?
좋아요.
You have to count all the possibilities.
Every single subset.
There is empty and there is 1, 2, 3, 4.
Yes.
All
Yep.
three.
Yep.
Oh.
Any ideas? Any ideas? You have to count the subset with 0 elements, the subset with 1 element,
오와.
the subset with 2 elements,
난 저 문제부터
3, 4,
What
all the way to 100. Or is there anything else you can do to solve it? Any ideas? See, just start writing like him. Just start writing. It doesn't matter if it's wrong.
How
I
can
mean,
you
it's right.
how
it's
can
right
you
subset.
write
How can you write that? Think about it. We've learned sums.
그래?
Sum.
How can you
sum?
write a sum? How can you write a sum? It's a sum.
위에 건 100개 중에 3개가 고르는 거고 밑에 거는 다 고르는 거.
뭐라는 거야?
Aha.
subset.
Now that looks like you can write it as a
S
sum.
만약에 S 다시 1부터 5까지는 S 다시 A 전부.
But is it going to be nice? That's the
그걸
question.
subset이라는 거 같거든.
아, 선생님,
Yes.
I can't.
So you can solve using the sum?
Can you? Well, write the sum. Try writing the sum. Doesn't matter. Try writing the sum.
What mean empty can be subset?
Oh my god.
So that means that if it has 0 elements, no elements,
아무것도 없다고요?
yeah, can be subset. Why?
Can subset all
Why? Why?
써도
Okay,
되니까?
if I take empty,
쥐땡이네.
what's empty and
잘못 알려줬어.
S?
Can you draw that?
Yeah, it's nothing.
huh?
Nothing exists in it.
지금 좀 맞지?
그래서
like-
subset이야.
It's like
아무것도
S,
없으니까 아무 데나 들어갈 수 있는 거지.
S prime is just
X.
empty. It's empty. There's nothing in there.
It can be everything.
Yes.
뭐야?
It can be empty.
모든 거에 subset이 될 수 있어.
없어.
아,
왜냐면 그 없으면 and
empty.
empty.
empty가 뭐예요?
Nothing.
Nothing.
에?
아무도 없어.
비어있다.
그냥
아,
그리고 or S
Nothing.
S.
OS가 뭐예요?
S.
왔지?
because it's either
Union.
or.
Yes.
아,
Or
너무
both.
어려워요.
It's like we have it's like we have S and then this thing it doesn't you don't even see it. So it's and is there any overlap?
아무거나 낼 수 있는 거.
No overlap. No 겹치다.
아,
겹치지
겹치는 게
않아요.
없다고요?
근데 이거 or or just s.
아니 이거랑 이거랑 헷갈리는데.
이건 and 이건 or.
and or로 안 외워진다고.
아,
잘안 들어 지금. 선생님 뭐잘안 들어 지금.
근데 이게
Try
n이야?
to write the
이게
sum. That's good
n이면
practice.
가운데 겹치는 것만
Try
있는
to write the
거잖아.
sum.
그리고
So what is
이거는
the sum?
이건 or 다.
So
이거는
it's
다잖아.
not 100,
그래서
right?
이거는 알겠다. 그래야
So
됐어
it's
이게.
100 to
아,
one
없애는구나.
thing. And the thing that
내가 쓰는
100 is choosing is changing.
나 진짜 천생이 수학의 머리를 갖고 있으면 해낼 거야.
So it's the sum. Yeah,
재수
100
없지.
choose.
수학을 다
Yeah.
안 할게.
But what is n ranging from?
이걸 참 어디서 본 거?
2.
and 100.
Yeah.
이렇게 손들고
So?
그 유치원생 땀나기처럼 이게 좋다.
아,
근데 문제가 뭐였지?
아니 100.
선생님 물음표가 없어서 문제인지 뭔지
100 choose
모르겠어.
I.
I choose I.
Yeah.
저 구하라는 거야.
이
그냥 이렇게 뭐?
But we don't know how to do that, do we? Huh.
저 분수를.
Well, that's
아,
a
103은
problem.
위에 있는 거야?
How do you evaluate that?
그 아래는 뭔데?
그 우리 그
Well, we have the
토탈이
last
뭔데?
one, yeah. But
전부.
do we know what this is?
전부
Do you know what
숫자에
that sum
뭐지?
is?
아니,
No.
저 분수를.
Okay, maybe try something else.
close form?
Well, we don't know the closed form. You don't know the closed form. It might be hard to find the closed form. I'm telling you that you can do this problem without knowing the closed form to that sum. You don't need to know that.
기부업.
You don't need to use the sum.
기구는 업하는
You
거.
can know the
기부업.
answer. Think about each element individually. Okay. So
안 기부업.
we need to look at 0 elements. 1 element. 2, all the way up to 100. Every subset, every set, everything possible. We can have
모든 게 다 가능한.
nothing, or we can have 1. So like we could have s prime equals 1. S prime equals 2. Etc. You could have s prime equals 1, 2. 1, 3. Etc.
If you choose 2 elements.
Yeah, or you pick 3. Or you pick 4. Or you pick 5. Or you pick 100. This is the way to start it. You should start by trying this. What? No.
수고했어?
No good. Don't try to do the sum. Big hint. Don't try to do the sum. You don't need to do that.
Then how can we do that?
그거라는 거는 백개는 백개.
Okay, you understand what you wrote?
이거 어떻게 쓰지? 이렇게 쓰는 거야? 뭔지 까먹었다.
In Korean, it is
가운데가
누가.
없어.
맞아
뭐가?
맞아. 모르지 너는.
Okay, so he writes, right? So you add 1 element subset, 2 element subset, number 3 element subsets, number 1 element subsets, everything.
자꾸 내걸다
So that is in sum.
내 딸랑이 건들지 마.
I equals 1 to 100.
내 딸랑이 건들지 마.
Idea? 100 to
아 갖고
9.
있으면 잘 아는다.
Plus
잘
one.
아는 말이야.
I, my team,
I think I choose same.
they are the same, yeah. But
공부 집중하고
I'm telling you. Okay, so they're the same. So what is that equal to? It's 2 times the sum.
아, 오케이.
다했다. 위에는 다 구했죠.
Except the problem is the 51. The 50, there's one of them. So it's 2 times the sum from till 49 plus,
저런 무슨.
right? Plus 1. So you could write that.
아래 있는 거는
You try writing it. Try writing it.
몇
Try writing it.
개가 있어?
That's
숫자가
good
있는
practice.
거? 아 그럼 아래는 끝났잖아.
Okay.
100. 그 아래는 100이다.
I don't know total number.
Good. So write as sum. Write as a sum.
네,
No, sigma. The whole thing, what
what is the sum? What is right as plus 1 for the 0 plus the 0 subset?
기록.
맞.
0, empty.
empty.
Okay,
아니지.
So we learned how to write a sum, right? Yes.
아, 이게 50.
How do we learn how to write a sum? It's like this.
Teacher, we can use constant right before the sum, like
2, yeah,
this.
2, yeah.
아,
2.
okay.
2 times whole sum. It looks like that.
말도 안 되는 논리를 펼쳐지는
Okay, the sum, right?
아무 뜻이 없는 거.
I equals. Okay, so we have 100. Choose some number. Let's just call it 100. Choose I.
저도 넘어.
What's the smallest I?
0? 3 아니야?
1. 1 element subset. Okay, what's the biggest I? 100. 100. And then plus 1 for the empty, which equals, this is exactly what we want. 1 plus 100, choose 1, plus 100, choose 2, plus. So this is the simple form. Okay. Now the problem is finding a closed form. We don't know the closed form. So that's annoying. We don't want to calculate all these things and add them up. So what can we do? He had a nice observation, although it's not going to help him much. I like the observation though. Alright.
How can you
Keep thinking. I want them to go through this process, but my hint, do you understand this? Yes, okay. Hint. Think about each element individually.
Not sum?
No, think about each element here individually. No, you keep going. Not yet.
하고 있어요.
He is ahead, so don't do what he's doing yet.
저는 쟤는 사람이 아니야.
Keep going this. So yeah, is that gonna work? Can you find the sum?
그러니까
That way.
시그마가 다 더하는 거니까.
뭔 식으로?
I can't do it.
Yes, it's very hard to find the sum, right?
아,
You don't know the answer to
very
it.
fast.
So many terms.
이거 어떻게 그래요?
컴퓨터 돌리면 되죠.
How do you know what this equals? You don't. Very hard to know. You know, there's 100 terms here, right? You don't want to calculate all this very big number. Okay. Think about each element individually. Is 1 in S prime? Is 2 in S prime? Is 3 in S prime? When I make a subset, I can ask. Here is like the big hint. Okay, I'm basically like giving you the answer. Is A in S prime?
안 보인다.
So A is in S, right? So let A be in S. So A could be like equal to 51.
Yes.
Is A in the subset?
No.
아,
Is it or isn't it? Alright, process that. Process it for a second.
What is A?
It's a number.
Ah.
Each one, it could be anything. For each one of these, individually look at them. Say A is 1, A is 2, A is 3.
100.
Yeah, is A in the subset? Is A not in the subset?
제가 풀 수 있는 건가? 문제 나도 모르겠어.
생각해봐. 할 수 있어.
What is individual?
Like one by one.
개별적으로 갖다.
아 맞다. Like 1 is 1 in subset.
단어 보는 거에 나와.
Is subset.
Teacher, that means that
Yes?
A
no?
can be include S prime or not include in S prime.
Yeah. Well, yeah, right? Because it could be an S prime or it couldn't. He's gonna get it. He's gonna get it. I
술
know.
먹는 줄
he's
알았어요.
so
I
close.
got. I think I got it.
Yeah. Okay, tell me how many subsets there are.
I don't know exactly that one. Okay.
답이 뭐야 이게요?
아니.
I didn't.
Don't share.
아 확.
했어. 히
네.
불었어.
와 진짜
어떻게
제 뇌를 끓여가지고 알으니까.
big hint.
Yes, that's a very big thing.
Very big hint.
완전 비킨체이지.
A can be in S prime or not.
S 프라임?
Is A in S prime? Is A not in
And
S
prime
prime?
그냥 A 다시.
응.
Can be
저기 다시 뭐였는데?
여기 다시?
이 다시가 그.
Wait again 다시 해봐. 뭔 소리 다시 얘기해봐.
A can be in.
그냥 편하게
A
담아
can
알려줘.
be in the S prime or not.
Or not?
Or not. In or not.
이건가?
Can A go anywhere else? Can A be out there in outer space? No. It can be in. Or it cannot be in.
Yes.
우리는 내가 없다.
There
포함돼야
are
된다는 거
only
아니야?
two situations, in or not, in or not.
응.
Yes.
그래서
There's 100
불렀어?
number.
다 안에 있겠지.
Yeah. Can it be? Okay.
할 말이 없으시지
See,
이제는.
look at each number.
Yes, each number.
Each number individually
Yes.
is 1 in S prime. Yes or no?
Yes.
How do you know?
모르는 거지.
How do you know? Is
A
it,
including 잠깐만.
A can be any of these.
S prime?
A can be 1 and 2, and but 1 is in the S prime or not, and 2 is same.
Is 2
in or
in S
not.
prime or
3
is
can
it
be
not
in or
in S
not.
prime?
S prime 뭔데?
그냥
The
우리가 구하는
subset.
거 그냥 subset.
We want number of subsets. We want to make a subset.
준이 안 해도 돼.
We look at each number individually. We say, do we add 1 to our subset?
그거 어떻게 알아? 아니 S 다시가 3이면은 1, 2, 3만 들어가는 거잖아.
그 생각.
No,
생각해봐.
only 3. 그러니까 individually, A can be 1 to 100, and 1 can be in the S prime or not, and 2 is the same, is in or not. There is only 2 situations. There is 100 numbers, and what?
말을 멈춰요.
He's right. He's giving you the answer. He's telling you answer.
우선
Each number is 1 in the subset.
나 문제
Or
어떻게
not.
알아?
Can 1 be out in outer space? No. It's
2분의 1
either in-
들어가? 2분의 1을 사용해?
들어가지 않아.
Yes,
It is
O and
one
X, O and X,
OX.
O X,
Is it
O
in?
X, and there is 100 number.
얘가 1이면 들어가거나 안 들어가거나 해서
우린 적었을 때.
음.
앞에 1이 있대. 그거 힌트는 가 봐. 저 if가 아니었어? 1이었네?
Yes, he got it.
Yeah.
뭐지? 그런 게 진정한 질문인 것들.
할수
아니
있어.
그게 중요한 건가?
Yes. There's only 2 situations and
그래서.
100 numbers.
예스와 너밖에 없대 나. 곱해줘 그러면?
Don't tell answer. Don't tell. Make them think. They don't want to think because they're scared. It's usually girls. I'm also like that. I get scared that I don't know the answer, and then I don't think. But if you think, you'll find the answer.
Each number is include
Or not.
yes, and there is 100 number.
Yes.
그래서
What is the answer?
what?
Don't say. Don't say.
아니, 영어를 잘 써 얼마나
Okay.
좋을까?
What? We need to make. We want to know all possible subsets. All possible.
다 다 들어가는 거?
One is in or not.
In.
Or not.
Or not.
Two, in or not. Three, in
or
or not. Four, in or not. 99, in or not.
2 곱하기 100 하면 안 되는 거야?
100, in or not.
That's not right, but this approach is.
아 이런 한국어로 하면 안 돼?
Think more deeply.
준이야 네가
하지 마.
왜 2 곱하기 100 하면 안 되는 거야? 그러면?
Similar. She
걱정하지
said
말고.
2 times 100.
릴렉스.
Similar,
대충
but
대충 뭘
Why 2
생각하냐.
times 100? Why?
yes.
Because each number has a 2 situations,
Yes.
in or not, and there is 100 number.
Yes.
오.
Yes.
And
Yes.
2 times 100.
That's not what 2 times 100. What you said was right. What you said was right. Your answer was not correct. What answer describes what you said?
슬프대.
You said there is in or not for each number. There's 2 options. There's 100 numbers.
You got the answer.
지혜 너가 이해하는 데까지 어디니?
100 numbers. 2 options for each number. So, what is it? It's 2. 2 option. 2 option. 2 option.
2하고 100. 2 power 100? 아니,
왜요?
Because 2 is the same and it is 계속 100번 곱해지잖아요. 아니.
연구해봐.
아니라는 거야.
So there's a 100 number and each number has a 2 situations.
Yes.
So we can say 2 times 2 times 2 times and it is again 100
Yes.
times.
Yes. Yes.
2 power 100.
Yes. And why is that the number of total subsets?
Why?
Yeah, why? So we have 2 to the 100. Why is this the number of total subsets? Why? Why is that correct?
Because a subset.
Why does it work? 질문이 있어?
No, there is not.
I expect them to be confused today.
초점 맞추세요 저기요.
내가 안 맞췄어.
초점 맞추라고요 하면서 그랬는데.
Why? Okay, so we have 100 possible elements. We want to see how many subsets can we make. We take each element and we say, is it in or not? Pick one. Number 2, in or not? Pick one. All the way up to 100. Okay? Every element can either be in or not. We've covered every single possibility. If we cover every single possibility, can there be any more subsets?
실성하기 실전까지 갈 것 같아.
Yes.
네가 이해를 해 내가
So
알 수
you
있어.
said each number has 2 situations and there's
Yes.
100 numbers. So
Yeah.
we can say 2 powers 100 and it can't be more 2 power 100 because
Yeah, why can't there be another subset? Why have we covered every subset?
there's only 100 numbers
And
and each number has 2 situations.
why are there only 2 situations?
In or not.
Yes. It can either be in the subset or it's not in the subset. That's it.
Alright.
풀었어.
풀었어? 내가 말 좀 해봐.
와.
Alright.
왜 안기고 하는 거 같지 쟤?
Nice question. I I like that one.
나이스.
코멘트 안에 댓글 많아요.
No, but then he said,
초점.
please focus.
포커스.
Who said please focus?
초점 맞춰달라고.
My
어,
brother.
강준구가.
Your brother?
My twin brother.
Oh my god, your brother is so funny.
쌍둥이래요.
Texas.
Yes, Texas.
Texas brother.
텍사스. 텍사스.
네.
Yes.
What are you doing?
I don't know.
Okay, I want the probability. That a subset has an odd number of elements.
요거는 뭐야? 저거에 들어가는 기준이 뭔데?
기준 만드는 거니까 만약에 A 다시 1하고 2가 정했어. 2안 1이가 1밖에 없어. 나머지 다 바뀌는 거잖아. 그럼 들어갈 때 안 들어가. 그치?
So what is next to has?
하나씩 보는 거. S 다시.
Has out?
밖에 안 들어가.
Has an odd.
100이면 다 들어가는구나.
S
원,
다시.
아,
100이다.
Sorry.
100이면 들어가지. 1부터 100이면 다 들어가겠지만.
1부터 100이면 그냥 다 들어간 거야?
그렇지. 그래서 이거는
아, 이제 이해가 갔다.
그래서 해야지 볼 때 얘는 들어가거나 안 들어가거나 둘 중 하나. 그렇지. 그래서 두 개씩 갖고 있는 게 100개가 있는 거잖아. 100까지 있는 거야. 그래서 똑같은 일이 100번 곱하기 이렇게 되는 거야.
근데 질문이 뭔데?
이거 토탈.
아, 토탈이 그거라고? 쉽네.
I think she understand.
쉽네 못한다.
She said it's easy.
Yes. 아 진짜.
It's not easy to find the answer. The answer is easy once you know the answer. It's very easy. But it's not easy to get the answer. Probability the subset has an odd number of elements. Okay. How does this work?
Different problem.
Yes. Sort of. Number of odd element. Oh wait, I meant to ask. Sorry. I didn't mean to ask. This is too hard. This is too hard for you. Well, no, this is okay. This is okay. It's okay.
Thank you.
Yeah. This is okay. This is okay.
어디가
어딨어?
헷갈린다.
Can you give us an example?
So an example would be like 1, 2, 3 would be an odd number because it has 3 elements. Wait. No, I don't want to ask this. What I wanted to ask was, has only odd numbers. Yeah, that's what I want to ask. Okay? So an example of this would be like 1, 3. I could ask the odd number elements, but that's too hard. I want to ask only odd numbers first.
So what was the answer of
Odd number of elements, like only odd number.
On number to 99?
I'm not gonna ask that. So in this one, it has only odd numbers, right? So it's like you could have 1, 3, or you could have like 97, 99, or like 5, 7, 23, 27, something like that. Only odd numbers.
So the element in the subset are all
numbers. So this would not work. 3, 4, 5. Because 4
Yeah,
is
4.
got
6 even number.
그렇죠?
So what we have to solve.
Think about it. You can do it. 할 수 있어. 아니면 그 probability. Okay. Number, subsets
이거랑 있나?
with
100개면 이거 아니야?
odd numbers.
그러니까.
Divided by
아,
number total
똑같이
subsets. Tell me what that is.
퀘스천. What? Oh my god.
I love her. Oh my god, you sound American.
teacher, so that 2 power
아까
the
뭔지
below
뭐였지?
bottom is 2
2 to the
power.
n. Yeah. Or 2 to the 100. Yeah.
저건 뭐야? 이거 위에
It's on
있는
the
거.
bottom, right? Because we figured that out.
Yeah.
Alright, what's on the top?
삼성.
You can do it.
저거는 100개 중에 홀수
This
먹는
one?
거야.
Yeah.
홀수 못 깬지 어떻게 알아?
그래서
Why?
A가 표현을
선생님이 아까 전체 숫자가 못 깼다 했어.
1,
이건 안
2
알려줬어.
and
저 N이라고
100 that is 50 odd number.
So
And what is this?
This
What is that equal to?
지금 뭐?
Yeah.
야 전체 숫자가 모르면 숫자 못 깼지 모르겠어.
The subset, it only has odd numbers.
어디가
I
홀수?
think
Okay, what is the bottom?
bottom
The bottom we found. Yes. What is the top? Yes, why?
이만큼 있겠다 중에.
50.
yes.
Yeah.
이거
Or
진짜
out.
얘 있는 거.
And this is equal to?
아니
Simplify.
아니 짝수냐. 홀수가 있는 거. 홀수가 있는 거.
Yes, you are. Are you kidding me? You're so good. You're doing well.
한번 해보자.
So 50 minus 1.
이게 홀수잖아.
So 2 to the minus 50, and that's 1 over 2.
그럼 여기서 홀수가 하나, 둘, 세 개.
Right?
이건 그냥 n개에서 빼기.
아니, 그거 괜찮아요. 그거 맞아요.
오.
2 to the minus 50.
이게
Okay.
짝수라면 6까지 있다면 바로 짝수는 이게 바로
A to the
나누기잖아.
minus
이게
B
홀수면
equals
이거
1
이거.
over. 아니, 이거 맞아요.
그러니까 이게 이거랑
Teacher,
똑같은 말이야.
I don't know.
할 수 있어.
Oh my god, I don't know.
Okay, total number of subsets.
What?
We found this.
Yes.
What is this?
마이너스
power n.
뜻은 안 배워서
2 to the 100.
가르쳐
Yeah.
내가 알려줘야 되라고.
Alright.
뺏겼어.
What is the number of subsets with only odd numbers?
잠깐 저 100개래. 전체 숫자 100개야.
그런 거.
아 뭐야? 이거 맞는데?
Only odd numbers. Only
이거
1,
맞잖아.
3, 5, 7, 9, 11, 97,
엄마야,
99.
There is the odd number.
Only odd numbers. No even number. Even number 있으면 안 돼요.
그러니까. Are there 50 odd numbers?
How many odd numbers are there?
50.
1, 3,
Yes.
50 odd numbers.
And we have to make subset only that number.
How many odd number in 100?
She just
15.
said 50.
맞아. 그래서 그다음
그래서 할 수 있어.
그래서 뭐지?
How many subsets with only odd numbers? There's 50 odd numbers.
And there is two choice.
In or out?
2 power 50 and
Divide
2 power 50 divided by 2 power 100.
simplify.
Then what does that equal to? Okay.
1 over 2.
Yeah. Very small probability. Okay.
Not that this answer.
Yes.
That is the answer.
Wow.
Easy.
쉽다고요? 뭐야?
Okay. Okay. What is
이제 마음이 들어가야 돼.
okay? What is the? That's a little hard. Okay, you don't have to solve for a nice number, but write in a sum the probability that the set, the S prime, contains all the prime numbers between 1 and 100. So what are the prime numbers? 2, 3, 5, 7, 11, 13, 17, 19, 23, etc.
Oh my god.
You have to know how many prime numbers.
I can't.
are 100.
Yeah, I mean you can figure it out.
Figure it out.
You should know that anyways, like it's just a nice thing to know. Okay, how many prime numbers? How many prime numbers from 1 to 100?
Prime number.
Well, you can get rid of half the numbers right away, almost, right?
Almost.
Because any even number's out. Any multiple of 3 is out. Any multiple of 5 is out. Alright, even numbers. Even, except 2. Out. Okay?
We have to write all of the number and out.
End in 5. No, you can just skip them. We can just skip them, right? End in 5, out. Digits add to 3. Add to a multiple. Oh, I should have proved that. Out. So multiples of 3, the digits add to a multiple of 3. Same with 9. So let's try it.
digit and
Digit is like 12. It's like 1, and then 2 is digits. And 1 plus 2 is 3,
it's
so divisible by 3.
yeah.
Okay, I'll have you prove that by induction.
Induction.
Yeah, I'll have you prove that by induction after you do this part.
Oh. Oh my god. 그 각자리 합이 왜 3회 배준이 그거를 인덕션을 해야지.
next class.
No next class.
매일매일 굉장히
We have
슬퍼요.
30 minutes.
Yeah, we have enough time to prove by induction. Fun proof.
So we have to write 1 to 100 and out.
Okay, well, after this, I'll give you this number. Through 23, so 1 to 25, but 25 is not in, is 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9.
25. There's gonna be less, right? Because the next one is 29, 31, not 33, not 35, 37.
Oh my god.
Right? You can just do it.
이거까지 공유해도 되겠다.
Do it?
Yeah!
쎄하다.
37, 39? No. 3 plus 9 is 12. That's divisible by 3. 41. 43. 45? Nope. No 5s. 47?
Yes.
49?
No.
No. 51? What's 5 plus 1?
No.
No, yeah. 53? Yeah. 55? No, 5. And if it ends in a 5, is divisible by 5. Okay? Alright. 55, 57, 59. Yep. 61? Why not?
This divided by 3.
No, 61 is okay.
61.
63.
No.
No. 67?
Yes. Oh, no?
No.
Why not?
Yes, yes.
Yeah. 69? 71. Yes. Alright, 73?
너무 커지는데요.
Yeah. 77? No.
Why?
11 times 7? 79? 81?
No.
83?
Oh my god, I write 100.
Yes.
Yes. 87?
음.
No.
Nope. 89?
Yes.
91?
Yes. No.
7 times 13?
Wow.
93?
No.
95? No.
안 보여
97?
이게. 더안
And
보여.
that's
진짜.
last.
Wow.
Alright, how many do we have?
Oh my god. 1, 2, 3, 4, 5, 6, 7,
1,
8,
2,
9, 10.
3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17,
Oh, wait,
18,
you
19,
did
20, 21, 22, 23, 24,
아,
25.
더안 보여.
Oh.
Interesting. 25. So, what do we need?
25?
I got 25 primes.
You got it? Oh.
Right? 25 prime numbers, right?
아, I don't know.
Well, how do you decide if it's prime? It can't add to.
So
여기가
좀 괜찮아.
문제가 그러니까.
That's terrible.
What is happening?
Happen.
You don't have to write them all. You can just write the ones that are prime. I have 25. I don't know if it's right. Could be wrong. 4, 5, 6, 7, 8, 9. Okay, 1, 2, 3, 4, 5, 6. So 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 25 primes. Alright, so what do we know? We know our set has at least 25 elements.
저도.
아, 이상.
아, no.
응?
저거 왜더 있을 수 있다는. 아니,
It can have more. It just can't have less. Why? Because we have 25 prime numbers, it needs to have all of them. Now, how many sets contain all the prime numbers? Okay, yeah, so we've got those 25. They have to be in. They have to be in.
I think you can do it now.
25 has to be in.
All 25 elements, the 25 prime numbers, there are 25 prime numbers between 1 and 100.
Yeah.
All of them have to be in. 뭐 하는 거야?
몰라요. 너무 안 끝까지.
아하.
내가 틀린
Everybody.
저렇게 하면 안 되니?
No? Yeah?
But
It is fixed. It has to all in, and there is only 75 options left. And in or out, in or out.
yeah. How many? What's the probability?
Probably one over 2 to the 25.
그러니까 내가 뭐가 이상해.
맞는 것 같아.
왜 마이너스 20이야?
고정되는 거잖아. 무조건 들어가야 된다고.
아, 오케이. 어쩐지.
Yeah, it can have other numbers. That's why the probability is actually bigger.
다른 말이지. 숨어지고 저런 거.
Okay, we have 25 numbers that are definitely in. What about the other numbers?
How many options?
How many options for everything else? There's 25 that are in.
I have a question. Isn't
Yes.
it possible that the subset is 1, 2, 3?
Yeah, but then what happens?
But 2 is not. 1 is not.
Yeah, so it's out. It needs to have every single prime number. Every single one of those 25 has to be in.
Fixed.
Fixed.
소수 25개가 들어가고 다른
무조건.
숫자 무조건 들어가고 다른 숫자가 들어가야 된다고?
안 들어가.
And no matter in or not.
그냥 컨테인스만 하면 되겠으니까 들어가면
All of them. It has to have all.
So not prime number is 75.
Yeah.
So it is each number of 2 situations. So there's 2 powers 75, and
Probability.
What's the total possibilities for subsets?
2 power 100,
Yeah.
and 1 over 2 power 25.
Yeah. Great. You did it. It's okay.
Congratulations.
Wait it.
Hooray.
Yeah. That's it. Okay. We know sets. Okay?
Yes.
We know sets. There's a lot of cool problems we can do with sets.
Oh.
But I'll bring more tomorrow, and now we will prove that if the digits sum to a multiple of 3,
Oh.
the number is divisible by 3.
we didn't prove that, and it's fine.
You can do it.
You can do it. You guys do so well today. Like honestly, you do so well. Don't worry. It's not easy.
This is their only in set notation. There's only union and
이게 눈 깜빡거리는
intersect.
Oh my god.
I know. So there's sometimes you'll see something like
There's
this.
see.
You'll see this, which means not A. So if like say A exists, not A is everything outside of A.
와우.
Sometimes it's written as like AC for A complement, but this is more common, at least in the US.
Korea student you see.
Really? You've seen that?
Yes.
Oh, genius.
I just see that only non-learned.
American, most people use this. This is more common.
So Korea is uncommon.
Yeah. So if this is B, what's not A and B?
That B minus B minus A and B.
Yeah, so it's yeah. Not A and B. Not A is everything outside of A. Overlap with B is in B.
I heard that in music that is the sign that 꾹 누르다.
Yeah. In music.
테너 투.
Yeah.
What?
So in music, if you see a bar, it's like slightly longer, like sharper touch. It's like a more
Stubborn.
bar.
중간에
Yeah.
빼지 말고 쭉 누르고 있어요.
And then the pointy one,
테너토라고
like this.
4센트랑 같이
In
나와요.
music, if it's like this, if it's like and then this, it means like a little pointier.
Point.
Yeah, and then like this is staccato, and then like
What difference?
and then this is this is like a little bit longer. It's the opposite of this. And then if it's like this is legato. If it's like this.
흔들리는 거는 이 트릭이 뭐였지?
This is like connected.
따라하는 거 있어.
And then pedal is like oh god, okay, I'll stop.
Music time.
Music time.
I need to practice today.
Really?
Yeah, I only practiced like 45 minutes. I need to do like 2 hours.
You happy to play the piano?
Yes.
I saw you playing Steinway piano.
In Kato Proprio.
The piano is very expensive.
Is that MIT?
Really?
That piano.
Oh.
It's in concert because my teacher, we have spring recital in MIT Killian Hall, and it's it's like a small hall.
You and everybody applause
No.
and
Well-
shout.
All teachers, students apply for, and the parents come. But the parents, they all like me. They all think, they're all like, I don't know why they like me. They want their kids to be like me, and I'm just like, no.
아줌마.
아줌마들. 근데 미국 아줌마. But there are a lot of them, they're Russian. They're Russian or they're like
Russian.
Russian because my teacher is Russian.
or they're like Chinese American. There's no Korean
Oh,
That's so sad.
right now. There's no
so
Korean.
Korean is stupid.
No, no, I know Korean, but he plays cello. He's very good. He is genius.
MIT. There is a Korean people in MIT.
Yeah.
Really?
Yeah, but they like most of them they go to high school. There's one kid, he went to military before he went to MIT though. My friend dated him. That's how I don't know him personally. I only know that my friend dated him, and so then I know of him. But then there's one guy I know. He's went to Stanford for undergraduate and then PhD at MIT. And he was my mom's student.
Oh.
Yeah. Genius. Okay, prove that if 3 divides the sum of the digits of n, then 3 divides n. Alright. That means divides. So, if 3 divides the sum of the digits of n, if the sum of the digits of a number is divisible by 3, then the number is divisible by 3. So let's take an example. 222. What's the sum of the digits?
6.
2 plus 2 plus 2 equals 6.
Yeah.
Is that divisible by 3?
Yeah.
Yes. Okay. Is this number divisible by 3?
Yeah.
Yeah. What's that divided by 3? What's 222 divided by 3?
74.
So, okay.
How can you prove it?
How can you prove it?
Induction.
You know how to prove this. You can do it. I want you to try.
Induction hypothesis. But you can't use like sum. So how can you prove that n plus 1
Well, is it n plus 1?
n plus 3?
Or you could say 3n. 아저씨.
할아버지.
He's like 할아버지. 지하철에 있는 할아버지. 해봐.
Sorry, 1?
No, this is divides.
이거
This thing means
분수 세번도 쓰.
divides. Oh my god, the markers are so good today. It's making me so happy. Okay, try. Right!
Okay.
I think we have to ask Google
No!
or Bixby.
Google, you don't need Google. You're smarter than Google. Probably not, but okay.
Google is stupid.
Google is stupid.
We are smarter than Google because we made it.
You made Google, exactly. Humans made Google. About 2 Stanford students.
Stanford students.
Or professors, I don't know, grad students. I don't know, they became like gazillionaires. They made so much money. Because they made Google.
Teacher, how can you base case?
Well, think about it.
Well, 1, 2, 3.
So, what is n? What is n? Right? N is the n, like, so n is the nth multiple of 3, right? Alright, and let's assume that n greater than 0, okay?
Oh, what is n of the?
n equals nth multiple of 3, right?
and then
n 번째 있는 숫자.
아니 저거 키우가 뭐냐고요.
th,
T.
n,
오.
like first,
second.
second, third.
아니 인덕션은 어떻게 써요?
You can do. What is the inductive hypothesis?
I can't.
Yes, you can.
strong induction.
There is induction in my house.
인덕션.
In electricity, but that's different induction. That's a bad kind of induction. Trust me. You guys, based on your reaction to trig functions, like, if you hate like this, if you hate that, you hate physics and calculus. You
I
hate
that.
induction. Yeah.
I hate all of them.
You hate.
What is that?
If you hate that, that's like, say you have a curve, like if you have some like thing,
Oh,
it's this,
오.
you seem to be.
it's a slope.
Oh, I don't like.
You know slope
Yes.
is the slope of on one point of all the different points of the curve. So the slope is changing,
Oh.
right?
High school students have to solve that.
오.
Yeah. Yeah. And then you can have like
이거로 가야지.
partials, right?
저거 재밌네.
So you could have like,
I'm humanity, not math or science.
you're humanities?
Huh?
You're humanities?
Yes.
Oh my god, no, you should totally do discrete math.
Huh?
This kind of math, you should do. You're very good.
My friends.
My friend was more greater than me.
Because he learned more.
Yes.
He's probably does competition.
I think I am also humanities.
Why? Why do humanities? Why? You don't need to.
My friend said that I am 100% humanities.
Why?
When I speak to them, because I use so much dad joke and
That doesn't mean anything. If I had grown up in Korea, I would be humanities. And I'm good at humanities, but like you guys, it's different because in actual math, like outside of high school math, it's less. This is like science. This is like engineering, like 공학. Right? 화학.
Jonha.
No. Not 공학. This is that kind of thing, right? This is not 수학. 수학 is different.
What is suak?
There are a lot of different types. This is one, what we do with the subsets, this course is one type of suha. You can major in this stuff I teach you in college. And you make more money than these people.
Make more money.
The stuff, the rich, like the money right now is all in like the algorithms, right?
Oh.
So, or like the computer. So it's like,
그러니까 얘는
you need to know this thing.
지칭하는 게 아니고 전체를
해봐.
맞아.
할 수 있다.
Ah.
So, base case.
Is 3?
First multiple of 3, yes.
Please divide by has 3 digits.
Yes,
Sum
it has 1
3,
digit.
so divide
Sum
by
is-
3
yes.
and it's right. Or
Yes.
inductive step.
Yes, that's the harder part.
I don't know inductive part.
You
Huh?
can do it.
If n is true and implies n plus 3.
Yeah, and plus first multiple of 3, right? So you're adding a 3, right? So you could say, if you say n is the nth multiple of 3, what's the n plus first multiple of 3?
No.
It's k, so if k, so, never mind, so just do n plus 3, just do n plus 3, okay? Just do n plus 3, that's easier. You have 2 cases,
2 keys.
yeah. Why do you have to have cases? Because it's a little bit tricky, right? Okay?
I need 2 keys.
Well, you have to have 2 cases, right? Because what if, so if n ends in a 1 or 0 or 2, it's easy, right? If the last, look at the last digit of n. Okay? Alright, base case. 3. 1 digit. Sum of the digits
3.
is 3, which is divisible by 3.
Yes.
The space keys?
Yeah. It's very easy. Now it gets a little bit harder. We have the inductive step. Okay. So, how are we going to do this? Consider the digits of n divisible by 3 and assume they add to multiple 3. Okay. So, we've got some n, right? And it could be a really big number. We don't know what n is, right? But we know that the digits add to a multiple of 3. Look at the last digit of n. And I'll give you case 1. Let the last digit of n equal k, okay? That's the last digit of n. The last number in, like, so 129, 9 is the last number. Okay? Case 1, 0 less than or equal to k, less than or equal to 6. Case 2, 7 less than or equal to k, less than or equal to 9. You have to,
Why we divide the cases?
because it's easier to do case 1. Because something is a little, so, you're looking at n plus 3, right? Okay? So, consider n plus 3, right? If the last digit of n is 6 or less, why is your job very easy? Think about it. You can do this, come on. You can do it. So, the last digit.
Oh.
Yes.
Why case 1 is easier than case 2?
Because if I add 3 to 0, what do I get?
3,
If I add 3 to 6, what do I get?
9. But this is over 10.
Yeah. So what happens?
So it gets bigger and
It changes the digit before, right?
oh.
So you have to, yeah. So you have to look at them separately. Okay, let's look at 123.
그 만약에 7이랑 9가 있으면
Okay?
더하면 10이 넘어가지. 그 새롭게 다시 또 오면 10이 넘어가니까 더 이렇게 되는 거지. One 132.
32.
Oh my god, I'm an idiot. Yeah, thank you.
Thank you. Bro, it's so hard.
It's not hard.
I can't so like it, bro.
Yes, you can. You're just tired.
We surrender.
No surrender. You can win.
나폴레옹에서 appears we surrender.
You can do math. You should do math, not humanities. You should do math, not humanities. Okay, think about it. We have n. We want to show n plus 3. What does this sound?
Teacher, I have a question.
Yes.
If you graduate, what will you do?
I don't know.
You go to the math company?
No. I hate companies.
What?
To be a pianist.
I wish. If I was good enough. The problem is to be a pianist you have to practice 8 hours a day.
8 hours?
6 to 8 hours at least, and I only have time to practice 2
Oh,
max.
wow.
It's like professional pianists, they all practice 8 hours a day.
Very 독종.
Very warm.
That's the only thing they do.
Piano warm.
It's the only thing. Doing one thing is bad. If you do one thing, then you're bored.
You lose another thing.
Yeah. It's like in Korea. You only do school.
Yeah. Yes.
You only do school and you lose everything else. It's
Yes.
bad.
I don't want to lose my hobby.
You shouldn't. You should just say no. You should just do your hobby and say, too bad Korean school. Okay, I'm bad. Don't repeat that.
Do my hobby and I will be expelled from it.
That's what I told to MIT. I said, too bad MIT. I do hobby. You'll be expelled from Korean school. Oh, wait.
What
Then
that mean? Case 1 and case 2.
Okay. We're looking at the last digit. Okay? So, it's the last one. We add 3 to the last digit, right? Because n plus 3. So we add 3. What happens if we add 3 to 0? Goes to 3. What if you add 3 to 6? 9. In the last place, right? But then what if you add 3 to 7?
10.
Yeah.
Over 10.
So what's the problem? It changes the second to last place. So let's say we have n, right?
Yeah.
N and n equals some really big number, right? So it's got so many digits, right?
Yes.
Then let's just say that n ends in 2, 7. If we add n plus 3, we get the same thing, but we get 3, 0. So that's why we need to consider. But if this had been say like a 5, we would get 2, 8.
Yeah.
And so it's only this one that changes.
Yeah.
But if it's 7 or bigger, they both change. The last 2 digits change.
Then it
So-
can be 3 digits change. And
No,
99.
Why can't you change 3 digits?
N plus 3.
You only add 3. Can you change 3 digits with 3?
Hey, 99 plus 3 is 121. I know 102.
Oh, true.
You change 3 digits.
Okay, but how can you make an argument? How can you make an argument even if you change 3 digits? You
Oh,
look at the last 2 digits.
a 2 digit?
Yeah, we don't have to solve this today, but if you look at the last 2 digits,
The only thinking time. Thinking how to do this.
yeah, you can think, but like it's actually not too bad. Because if you look at the last 3, you know, say you have 299
299.
as the last 3,
Yes, yeah.
you add 3.
302.
So it's gonna be something about like the property of the sum of the digits, right? So you're gonna have to make an expression, let the sum
Yeah.
of the digits
Yeah.
of something be something. And then I want you to think about what happens when you add 3. You could use mods.
Mod?
Mod.
Well, why does using mods help you? Why does using mods make it really easy?
Because mod 0 mod 3 is divisible by 3.
Yeah, and then you can just add 3 to the 0 mod 3, and then, right?
Mod is college math.
No, I learned it when I was a little kid.
Really?
Yeah.
Kid?
What teacher said that
Child.
we don't learn mod?
Yeah. You asked your teacher!
I know, I don't ask what teacher tell us that we don't learn mod.
Who asked the teacher?
I don't, that's not my friend, but someone asked how to prove, but teacher said that mod is useful way, but we don't learn that.
Yeah, they don't usually teach it in high school, but my dad taught me, like 5 years old you can learn.
Oh,
5 years old you can learn mod.
you're a
It's-
genius.
No! It's not, it's just a clock. It's just a clock. When you learn the clock, you can learn mod. You learn mod 12. When you learn a clock, you learn mod 12. Right?
Yeah,
Okay. Think about this.
yes.
Think about problem. You seem very tired.
This is so much.
No homework, no homework. Just think. Oh my god, everybody's so dead. So am I. I'm dead too.
My dad is